Alrighty, hey Honors Chemistry, just in case the simulation is not working on your Chromebooks or on your cell phones, I wanted to provide a video of us trying to collect some sample data together. So as we mentioned in class, we probably want to get some measurements of pressure with respect to volume and see how pressure changes with volume quantitatively. So I have this syringe here with a piston that I could move up and down. And as you can see, with me moving up and down the piston, the particles are moving closer and further away. And it looks like the pressure gauge here goes crazy. So this big circular thing has my pressure gauge, and it's recording my pressure in hectopascals. And I wrote over here that 1 hectopascal is 100 pascals. And we'll use that later if we want to calculate different units of pressure. And then the syringe here records my volume in milliliters. So we are changing the volume. We get to control the volume. So that's going to be our independent variable. We are changing it. The pressure is changing as a result of the volume. So our pressure is going to be our dependent variable. So let's start recording some measurements here. So right now my volume is at 50 milliliters. So I'm going to write that down. It is 50. And my pressure gauge is reading 1,000 hectopascals. So I'm going to write 1,000. Now, if you get a chance to try and count what each dash means, each dash is 50 hectopascals. So that means each smaller dash is 50 hectopascals, and then there are 4 small dashes with large big dash. So every time there's a thicker big dash, that's about another 200 hectopascals. So the small one is 50, 100, 150, 200, and then 250, right? So we're going to record the next measurement. We're going to change the volume to about 40 milliliters. So I'm going to push the volume down to 40 milliliters. And we can see that my pressure gauge changes. And it looks like it changed by about 5 marks. Each mark is about 50 hectopascals, and you could count it to prove yourself. So it's looking like at 40 milliliters, my pressure has jumped to 1,250 hectopascals. So at 40 milliliters, my pressure has jumped to 1,250 hectopascals. Let's do a couple of more measurements. If I move it all the way down to 30, squishing it all the way to 30, it looks like my pressure jumps to about 1,700 hectopascals. So I'm going to write that down. 30 is about 1,700 hectopascals, okay? And then let's squish it all the way down to 20, or push it all the way down to 20 milliliters, and it looks like my pressure gauge is 2,500 hectopascals, and it looks like it won't go any further. I wonder if we could predict or figure out mathematically what would the pressure be at 10 milliliters. So what you are going to do now with this data is you should try to plot this data and look at the relationship between pressure and volume. You may want to graph it. You may want to try and see if you could come up with an input-output relationship. If you want, you could stop the video here. I think I'm going to record a couple of more measurements. So if I go to 60 milliliters, it looks like my pressure has been dropped to about, let's see, 1,950, 900, 850 hectopascals. So if I went to 60, I get 850 hectopascals. If I open it up to 70, I get about, let's see, 750 hectopascals. So if I move it to 70, I get 750 hectopascals. And let's just do one more measurement. If I move it all the way to 100, it looks like my pressure is 500 hectopascals. So 100, 500 hectopascals. So how about our job is to predict or figure out what the pressure would be at 10 milliliters. All right, so hopefully you could use this video to help you collect data and think about the quantitative relationship between pressure and volume.